Hi all, welcome to the Brilliant Qatar YouTube channel. Today is 24th January. It's time to start our countdown. You know that we have 1 month before the board exam. 24th February the board exam is starting. So the team Brilliant is all set to help you in this big battle. Today onwards, every day from 9 PM to 10 PM, the faculty group from the team Brilliant will be available with plenty of questions. We will discuss the most probable questions for the board exams. So first of all, I request all of you to share this our channel to your friends. Let all of them enjoy this session. So in today's session, we are going to start physics. Myself, Jibish, Faculty of Physics of Brilliant Group of Institution. We will be discussing most probable MCQs in today's session. You know the importance of multiple choice questions in the board exam. 18 MCQs are there. 18 MCQs including 2 assertion reason questions. And this is the area where most of the students are losing marks. You know that a very silly mistake will lead to a wrong answer. So students need to be very careful while answering multiple choice question. So we will be discussing, we are trying to discuss all probable questions in this session. So I'm expecting a complete attention from all the students. Make your comments while discussing each questions. You can try the questions by yourself. You can comment your answers. So without wasting the time, I'm going to the first question. Today we are discussing electrostatics. You know that electrostatics consists of 2 important chapters. The first chapter, electric charges and fields, and then number 2, electric potential and capacitance. So together we are calling it as electrostatics. So we'll be discussing the most probable and the repeating questions from this chapter. So I'm going to the first question. Question number 1. So thus, the unit of electric field intensity is. This is a very simple question, you know that. In this session, multiple choice question part, in this section, there will be direct question, there will be numerical, there will be application type questions. You can see all type of questions in it. So the first question is very simple. What is the unit of electric field intensity? So just recall the idea of electric field intensity. What is it? Electric field intensity is the force experienced by a unit positive charge kept at a point. So you can just write the formula E is equal to F by Q. This is the basic formula which we learned for electric field intensity. They are asking what is the unit of this physical quantity. What is the unit of SI unit of force? SI unit of force is Newton. So we are writing Newton per. What is the SI unit of charge? It's Coulomb. So Newton per Coulomb. This is the unit which we studied from the direct formula. But my dear students, look at the options. You can't see that option in this given answers. So think about, is there any other formula for the electric field intensity? Of course, in the second chapter, we have studied a relation between electric field and potential. What is it? Electric field and potential, you know that E is equal to what? V by D. This is the relation between electric field and potential difference in a uniform electric field. Now tell me, what is the SI unit of potential? It is volt. SI unit of potential is volt. And SI unit of distance is meter. Look at this. What is our answer? Volt per meter. Check. Yes, it is there in the given options. Our answer is option A. Option A. I think most of you got this answer. It's a very simple question. So the SI unit of electric field intensity is volt per meter. I think it's clear. So I'm going to the second question now. Question number 2. You can comment your answers. You can check with the answers that I'm writing on the board. Look at the second question. Work done in carrying a charge Q from A to B along a semicircle is. Before answering this question, my dear students, you can see many questions of this type in your past papers, past question papers. If you are referring, you can see this type of question. Work done to move a charge from one point to another, from one corner to another corner of a square. So many such questions you can see. So how to calculate the work done in this case? We have a formula for the work done, basic formula for work done in mechanics. What is it? Work done is equal to force and displacement. In electrostatics, if such a question comes, calculate the work done means, please don't go with the basic formula, force and displacement. You're not going to get the answer if you're using that formula. Here, my dear students, please note that any work done question, if they're asking, work done to move a charge, we have to use the idea that is work done is equal to change in energy. So you can make a note. Work done, if they're asking, use this idea, you can easily find the answer. Change in energy, that means final energy minus initial energy will give you the work done. Listen here, what is the meaning of this question? There is a charge at the middle. You can see at the middle, there is a charge. Here, there is a charge of plus Q. And they are asking what is the work done to move a charge Q from A to B along a semicircle. So we have to move this charge along the semicircle, right? Please note that electrostatic force is a conservative force. Conservative force means what? Work done is independent of the path. So why the path is mentioned means it is just to create the confusion. You don't need to bother about the path. They can move it along the semicircle or any other path, leave it, check the initial point and final point. What is the initial point? It's A. So we are placing a charge Q at the point A. And then what is the final point? It's at B. So final point is A, initial point is A, final point is B. What is the formula for electric potential energy of a system of two charges? I think all of you know the answer. Potential energy of a system of two charges, U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. It is the expression for the potential energy of a system of two charges. So take the initial system. Initial system, you can see there is small q, there is capital Q. So the initial energy will be 1 by 4 pi epsilon naught Q. What is the distance of separation? It is the radius. So the initial potential energy of this system is 1 by 4 pi epsilon naught Q by R. And we are moving this charge from A to B. So final point is B. You can see this distance remains the same. The charge remains the same, the distance also remains the same. So what is the final energy? So if you are taking this as U1, final energy U2. Again 1 by 4 pi epsilon naught Q by R again. Look, initial energy and final energy are same. So what will be the work done? Work done is equal to the change in energy, it's equal to 0. So please note that if the distance is same, initial distance of separation between the two charges is same as the final distance, then what you can see is the work done will be 0. So what is the answer? Here the answer is option D. So it is not only for this particular question, in any question related to work done, you have to use this idea. I think this answer is, this question is clear for all of you. So I'm going to the third question now. Question number 3. Look at this. The electric field at a small distance r from an infinitely long plane sheet of charge is directly proportional to. Electric field intensity due to a plane sheet of charge is directly proportional to. Chapter number 1, applications of Gauss theorem. Number 2, electric field due to a plane sheet of charge. Do you remember? If you are taking a plane sheet, let it be a plane sheet, alright, and I'm taking a point P. Look at this, it's a point P which is at a distance r from the plane sheet. Recall the formula. So you know the importance of studying the formulas. So what is the formula for electric field intensity? Electric field intensity, E is equal to, I think all of you know it, it is sigma by 2 epsilon naught. This is the formula for the electric field intensity. E is equal to sigma by 2 epsilon naught. What is sigma here? Sigma is the surface charge density. What does mean by surface charge density? Surface charge density is, charge per unit area. So total charge is Q and the area of the plate is A, means sigma is equal to Q by A. So what is the formula for electric field now? Q by A into what? 2 epsilon naught. 2 epsilon naught. This is the formula for electric field intensity in terms of Q. Now what is the question? The point is at a distance r, and the question is given as capital R. Yes, the distance is capital R. From an infinitely long plane sheet of charge is directly proportional to. Look at the option. You have to write the answer in terms of R. How this electric field is related to R value. My dear students, you can see that in the formula. Is there R? R is not there. What does it mean? It is independent of R. Electric field intensity is independent of R. So which is the right answer? Independent of R means, look, option R square by 2, R by 2, R raised to 0, R raised to 4 by 4. Independent of R means which one? It's option C. R raised to 0 means what? 1. So there is no R in that option. So the answer for this question is option C. Clear or not? So please note, these are repeating question. It is independent. So electric field intensity due to a plane sheet of charge is independent of the distance. I think it's clear. So I'll be going to the next. Before starting this question, I need to make a point very clear. Like you may not be getting the time to write the question because we are going very quickly because we need to cover maximum questions in this shortest time. So after the session, those who need the PDF of the question discussion, we will be sharing it. The students of Brilliant Group of Institution will get the PDF in the respective class groups, and others can contact with our number. You will get, the number will be showing through the video, so you can contact with that number, you will get the PDF of this. So please note that. Okay, so I am going to the fourth question, question number 4. A dipole is placed in a uniform electric field. Its potential energy will be minimum when the angle between its axis and field is. Again, it's a formula based question. Potential energy is minimum. Potential energy of what? Potential energy of a dipole in a uniform electric field. Recall the formula. What is the equation for potential energy of a dipole? Potential energy of a dipole is U is equal to, do you remember? It is minus P dot E. Minus P dot E. So it is equal to minus PE cos theta. This is the formula for potential energy. So they are asking at which angle the potential energy will be minimum when the angle between. So what is theta in this formula? Theta is the angle between P and E. P and E. So we have, there are different cases. So let us take theta is equal to 0. What is the meaning theta 0? Theta 0 means it is parallel, right? Theta is 0 means angle between vector P and vector E is parallel. So if this is the direction of electric field intensity, theta 0 means the dipole should also be in the same direction. So if you are substituting that value here, you get U is equal to minus PE into what? Cos 0. What is the value of cos 0? Cos 0 is equal to 1. So we get minus PE. Minus P. Now we can think about the other possibility. If it is perpendicular, theta is equal to 90. We get cos 90. U is equal to minus PE cos 90. Cos 90 is equal to 1. So what is the result? Cos 90 is equal to 0. We get 0. And then theta is equal to 180 degree, the next possibility. What is the meaning of 180 degree? Anti-parallel. Electric field towards right and dipole moment is towards left. So what will be the result? U is equal to minus P into cos 180 is minus 1. You get minus P into minus 1. What is the result? P. Now compare these three values. When theta is 0, you can see it is minus P. When theta is 90, energy is 0. Theta is 180, it is P. Now tell me, in which case it is minimum? Minimum means minimum value. Clearly you can see it is when theta is equal to 0. So very simple question, my dear students. Please note that the energy will be minimum when theta is 0. Theta 0 means the dipole is aligned parallel. And when theta is 180, the energy is maximum. Okay, so what is the answer for this question? Theta is equal to 0. Option A is our answer. Option A. Okay, now in this question you have to note one more important point. In some question you can see that calculate the work done to rotate a dipole from stable equilibrium position to unstable equilibrium position. Such question you can see. So what is the meaning of this equilibrium? Equilibrium means, you know that in mechanics, equilibrium means if net force acting on a body is equal to 0, that is called equilibrium. Net force, net torque. Okay, so these two cases, that means theta is 0 and theta is 180, both are equilibrium position, because in that those angles the torque will be 0. So this is equilibrium, this is also what? Equilibrium. Now students may have confusion which is stable equilibrium and which is unstable equilibrium. How can you understand that? Stable means, like here you can see the energy is minimum. Minimum energy means all objects will be stable. Alright, so which is stable equilibrium position? The theta 0 is called what? The stable equilibrium position, stable. And unstable equilibrium position means it is theta is 180. So these two names you have to note. in some question they won't mention the angle, they will simply say that stable equilibrium, unstable equilibrium. So stable equilibrium means you should understand theta is equal to 0, unstable means theta is equal to 180 degree. Hope this answer is clear for you. I am going to the next question. Question number 5. Look at this. A charge Q is enclosed within a cube. What is the flux through one of its face? It's a repeating question. You can see this type of question in many papers. Charge Q is enclosed within a cube. What is the flux through one of its face? Flux. How can you find flux? Through an enclosed surface, we know that we will be using Gauss theorem. Recall the statement. What is it? Gauss theorem states that the total electric flux passing through any closed surface is equal to 1 by epsilon naught times the net charge enclosed by the surface. Right. So here, what is a closed surface here? A charge Q is enclosed within a cube. So cube is our surface. Okay. Look at this. Let it be a cube. A charge Q is enclosed. So inside this cube, you can place a charge. See. What is the question? What is the flux through one of its face? They are not asking the flux through the entire cube. You have to find the flux through only one face of the cube. But Gauss theorem, you know that. Using Gauss theorem, we will be finding the flux through a closed surface, the entire surface. But we have to find flux through one face. Look at this. This is one face of the cube. So we have to calculate flux through one face. Phi, total flux using Gauss theorem, phi is equal to what? 1 by epsilon naught into Q. This is what? The total flux, which is total flux because it is flux through the entire cube, which means how many phases? So you can see that there are 6 phases in the cube. So we have to find flux through one phase only. This is the total flux through the entire 6 phases. So one phase will be this divided by 6. So we get what? Q by 6 epsilon naught. Q by 6 epsilon naught is the answer. So I think it is clear for you. Q by 6 epsilon naught. Okay, somebody is having a doubt. Yes, I can see a message. Hadi, what's the doubt? You can ask. Students, you can comment your answers. Or if in case any doubt, that also you can ask in the comment box. Okay, I'm going to the next. Once I get the question, I'll answer it. Okay, I'll be going to the next. It's clear, I think. So next question is question number 6. An electric dipole is placed in a non-uniform electric field. What acts on it? Simple question only, but repeating. Electric dipole is placed in a non-uniform electric field. Non-uniform electric field. My dear students, we studied that like if a dipole is kept in a uniform electric field, if this is a uniform electric field of intensity E, and if we are placing a dipole in it, consists of 2 charges minus Q and plus Q. We had a derivation for the torque acting on it, right? In that derivation, we made a very important point that if you are keeping a dipole in a uniform electric field, the net force acting on the dipole is 0. That's an important point. In a uniform electric field, net force is 0. That means the dipole will be experiencing only the torque. It will rotate. But here the question is, it is a non-uniform. See, placed in a non-uniform electric field. If the electric field is non-uniform, you can understand, you can note that the dipole will be experiencing both a net force and a torque. So you can look at the option. The option A is only torque, option B is only force, option C is both A and B. Both A and B. So what is the answer? The answer is both A and B. It will experience both. But please be careful. Please read the question carefully. If it is a uniform electric field, the answer will be only torque. Non-uniform electric field, it will experience both force and torque. I think it's clear. So I'm going to the next. It is question number 7. Two plates are 1 centimeter apart and the potential difference between them is 10 volt. The electric field between the plates is. It's again a simple question. There are two plates. Plate 1, plate 2. Okay, what is the distance of separation? The distance is 1 centimeter. And the potential difference between this is 10 volt. They are asking what is the electric field between the plates. There is a direct formula, easy formula. E is equal to what? V by D. In a uniform electric field, this is a relation, but at the same time you have to note that what is the relation between electric field and potential in a non-uniform electric field. If the field is not uniform, we have to use E is equal to minus dV by dr, negative potential gradient. Here no need to go with that because it's uniform, two plates are there. Substitute 10 divided by what is the distance? Distance is given as 1 centimeter. 1 centimeter is the distance. So potential is in SI unit, but distance is given in centimeter. You should convert it to meter. 1 centimeter is 1 into 10 power minus 2 meter. This minus 2 will go up. So we get 10 into 10 power 2. What is the answer? Simple again. We'll get it as 1000. 10 into 10 power 2 means 1000 volt. Option C. Very easy, right? So please, students, please study the relation between electric field and potential. Okay, next question. Look at this. The angle between the electric dipole moment and the electric field strength due to it on the equatorial line is. Angle between the electric dipole moment and the electric field strength on the equatorial line. In the first chapter, electric charges and fields, you know that one of the probable 5-mark question is electric field intensity due to a dipole. We have two important derivations. One is for the field on the axial line and the other is the field on the equatorial line. Yes or no? So, if this is the dipole, minus q plus q. What is the direction of dipole moment? All of you know that direction of dipole moment is from negative charge to positive charge. So, it is from minus q to plus q. So, as per my diagram, the direction of electric dipole moment will be from left to right. Yes or no? Yes. On axial line, we found the field. Axial line is here. What is the direction of electric field intensity? This is the axial line, and please note that the direction of electric field intensity on the axial line is towards right. As per this alignment, you can see the direction of electric field is towards right. So towards right means what is the angle between the dipole moment and the direction of electric field on axial line? They can ask either axial line or equatorial line. So on axial line, both are towards right. So what is the angle? Angle will be 0 degree. Remember, that's on the axial line. If the question is on the axial line, the answer is 0. But in this question, it is on the equatorial line. Hope all of you remember the derivation. We have taken a point here on the equatorial line. The distance of separation is r. And what was the direction of electric field? Towards left. So dipole moment is towards right and electric field is towards left. So what is the angle between these two? One is towards right and other is towards left. Angle will be 180 degree. 180 degree is the angle between dipole moment and electric field intensity on equatorial line. So the answer is option C. Okay. Please comment. There is a question like, can you explain the 7th one again? Sunnaya Fatima, let me go. I think others can copy this. If any problem, like, you can comment. If you want to repeat any question, those who are watching, please make some comments. Okay. Yes, this is the 7th question. Fatima, like, this is an easy question. The distance of separation is given 1 centimeter. Potential difference is given 10 volt. They are asking what is the electric field intensity. We are directly using the relation electric field is equal to V by D. V by D. V is given as 10, distance is 1 centimeter, we are converting it to meter, 1 into 10 power minus 2, this minus 2 will go up, 10 into 10 square, we get 1000 volt. I think it's clear. So, going to the next. Question number 9. 2-point charges plus 9E and plus E are at 16 centimeter away from each other. Where should another charge Q be placed between them so that the charge placed is in equilibrium? This is also a repeating question. Please read it carefully, understand it. There are two charges. What is the first charge? First charge is plus 9E. First charge, plus 9E. And the second one is plus E. They are kept at a distance of 16 centimeter. So, I'm just marking here. This is the point where I am keeping plus 9E, our first charge. Plus 9E. And at a distance of 16 centimeter, there is another charge. What is it? It is plus E. So, you can see both the charges are positive. Plus 9E and plus E. And what they are asking is, where should another charge Q be placed between them? So in between these two charges, we have to place another charge. But what is the significance of that point? So that the charge placed is in equilibrium. That means if I am placing that charge Q here, it should be in equilibrium. What is the meaning of equilibrium? We have already discussed that equilibrium means the net force should be 0. So at what point we have to place this charge Q for it to be in equilibrium? So the net force acting on that will be 0. Right. So what you can understand is on this charge, how many forces will be there? We are keeping in between these two, means surely this charge can exert a force on this, and this plus E charge also can exert a force. So there will be two forces, and you can see that since this is positive, the force will be repulsive. This is positive, again the force will be repulsive. So there is no question about their direction. They are oppositely directed. One force will be towards right, another will be toward left. Now if their magnitudes are equal, it will be in equilibrium. That is the idea we have to use to solve this kind of question. Equate the magnitude of force. So the question is, where is this charge? You can take that charge is at a distance of x. From which charge? Plus 9E. You can take the distance from other charge also, no problem, it's our choice. So I am taking here the charge Q is placed at a distance of x. Okay? If this is x, what will be this distance? You can see the total distance is 16 centimeter. So if this is x, surely this will be 16 minus x. So one distance I am taking x, then the other will be 16 minus x. Okay, now we can write the force. What is the force formula? Coulomb's law directly. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So what is the condition for equilibrium? For equilibrium, force 1 should be equal to force 2. So condition is F1 is equal to F2. F1 is equal to F2. What is F1? 1 by 4 pi epsilon naught Q1 Q2. Q1 is 9E. Q2 is Q by the distance. What is the distance between these two? It is x. So Q1, Q2, 9E into Q by x square is equal to the second force. Second force is between this Q and this E. So again you can write 1 by 4 pi epsilon naught E into, this charge is E into what? Q divided by, what is the distance of separation? It is 16 minus x. So 16 minus x, the whole square. This step is clear now? So we are equating the magnitudes of the forces. Cancel. 1 by 4 pi epsilon naught will be cancelled on both sides. E will be cancelled on both sides. Q will be cancelled on both sides. So many common terms you can see. Write the rest of the term. 9 by x square is equal to 1 by 16 minus x, the whole square. By solving this, we have to find the value of x. That's our answer. Now you can see there is an advantage, like 9x square, 16 minus, all are perfect squares, so you can easily take the square root. This equation will become very simple. Square root of 9 is 3. Square root of x square is x, is equal to 1 divided by 16 minus x. Now we can cross multiply. So 3 into 16 minus x is equal to x. So 3 into 16 is 48 minus x is equal to x. 48 minus 3x is equal to x. Minus 3x will go to the other side. 4x is equal to 48. X is equal to 48 by 4, which is equal to 12 centimeter. So 12 centimeter from where? We have taken x from plus 9e. So what you can see is this charge, for it to be in equilibrium, we need to place that charge at a distance of 12 centimeter from where? From plus 9e. From plus 9e. So what is the answer? The answer is option B. Option B is our answer. Is it okay or not? Important question. We are using the idea of superposition principle. To find the net force, we have to take the vector sum. So that's the idea we are using here. There are two forces equating the magnitudes. Clear or not? I think I can go to the next question now. Question number 10. The total electric flux leaving a spherical surface of radius r meter enclosing an electric dipole of charge q is. Easy question. Okay, so there will be some questions like this directly without wasting time. You can answer it in 5 seconds. Total electric flux leaving a spherical surface. So the surface is a sphere. Let it be our spherical surface. Okay. Total flux leaving a spherical surface of radius r meter enclosing an electric dipole of charge q. My dear students, what is dipole? Dipole means it's a pair of equal and opposite charges. So here q is a charge, which means in that dipole, what you can see, there will be a minus q charge and there will be a plus q charge. So what is the net charge? Net charge of the dipole is 0. Net charge is 0. Gauss theorem. Total electric flux passing through any closed surface is equal to 1 by epsilon naught into net charge. But net charge is 0 here. So what is the answer? 1 by epsilon naught into 0. We'll get it as what? 0. So very, very easy question. Net charge of a dipole is 0. So net charge enclosed by the Gaussian surface is 0. So the answer is 0. Okay. I think some... No, fine. No more doubts are there? Okay. So I'll be going to the next question. Right. I think this is also very clear. Next one. Question number 11. An electric dipole of moment P is lying along a uniform electric field E. Work done in rotating the dipole by 90 degrees. Again a question related to work done in rotating a dipole. An electric dipole of moment P is lying along a uniform electric field E. So along a uniform means you can see that initially what is the angle between that electric field and dipole? It is 0 along the line, along the electric field, 0. And they are asking the work done in rotating the dipole by 90 degrees. You have to rotate it 90. There is a direct formula. What is that? Work done in rotating a dipole. I think all of you know it. If you don't know, just study it. Work done in rotating a dipole, the formula is W is equal to, this is one formula that we are getting while deriving the equation for potential energy of a dipole. What is it? It is minus PE into cos theta 2 minus cos theta 1. This is the formula for calculating work done in rotating a dipole. So you can substitute minus PE. What is P here? P is the dipole moment, E is the intensity of electric field, into cos theta 2. See, cos theta 2 minus cos theta 1. What is theta 1? Theta 1 is the initial angle. Theta 2 is the final angle. So it is given that lying along means theta 1 is 0. And you have to rotate it through 90 degrees, which means theta 2 is 90. So what you can write here, cos 90 minus cos 0 equal to minus P into, what is cos 90? Cos 90 is equal to 0 minus cos 0 is equal to 1. So we get minus P into minus 1. So the answer is P. Work done in rotating a dipole is P. P means option A is our answer. So please note this. I think there is a question from Sanjay. Sanjay is asking, sir, the ninth one, what if we took X value on the other side of the charge Q? Will the answer change? Sanjay, never. The answer will be the same. But you will get, like, I'll show you. If you are taking X from the other side, what we will get? Here the answer is 12 centimeter only we got, right? 12 centimeter is our answer. So if you are taking the X from other side, you will get X as 4 centimeter. 4 centimeter from where? Plus E. So you have to check such an option is not there. So 4 centimeter from plus E is not there, which means you have to think if that is 4 centimeter, other will be surely, of course, it will be 12 centimeter. So 4 centimeter from plus E means it will be 12 centimeter from the other charge. That's the idea you have to use. I think it's clear, Sanjay. So I am going to this question again. All of you copied? So next, so work done in rotating a dipole. Please note this formula, important. Question number 12. An electric dipole consisting of two opposite charges, 2 into 10 power minus 6 coulomb each, separated by a distance of 0.03 meter, is placed in an electric field of 2 into 10 raised to 5 Newton per coulomb. The maximum torque on the dipole will be. Direct question. Recall the formula, substitute, calculate. Okay, maximum torque. That's what they are asking. Okay, so what is the formula for torque? Torque is equal to, all of you know that torque is P cross E, vector P cross vector E. Torque is equal to P cross E. This is in vector form. What is the magnitude of torque? Magnitude of torque is equal to P sin theta. Where P is the dipole moment, E is the electric field intensity, theta is the angle between P and E. Now, some students may have a doubt like the theta value is not given here. Then which value we will substitute? No need to worry. Why? Because what is the question? They are asking maximum torque. Maximum torque, it's a sine function. So for the torque to be maximum, you know that sine function should be maximum. What is the maximum value of sine function? It is 1. So you can take sine theta is equal to 1. So the formula will become tau max is equal to maximum torque is P. P value, is it given? No. P is not there in the question. But P you can easily find. P is the dipole moment. What is the formula for calculating dipole moment? Charge into distance of separation. The formula for dipole moment is Q into 2L. 2L is the distance. Okay. So Q into 2L into what? Electric field intensity. Now you can substitute the value. Okay, what is Q value? Charge is given as 2 into 10 power minus 6. 2 into 10 power minus 6 is a charge. Into 2L. This is one mistake that students are making. What is 2L? 2L is the total distance. See, if minus Q is here and plus Q is here, this total distance is 2L. That distance only is given as 0.3. So please don't take L as 0.03. 0.03 is 2L. Okay, so we can directly substitute here. 2L is 0.03, 0.03 into the electric field intensity. Directly it is given 2 into 10 power 5. Okay, so what will be the answer? 2 into this 10 power 5 is there. So I am multiplying the 0.0 with 100 will become 3. So 3 into 2 is 6. So 2 into 6 into, we get 10 power minus 3. Okay. So 12 into 10 raised to minus 3 Newton meter is our answer. Check the options. It is 12 into 10 power minus 3 means it's option. Clear or not? Yes. I think this question is also clear. Direct question, by heart the formula. So again I am telling you, my dear students, by heart all the formulas. Okay, if you know the formula, it's half is done. Okay, next question is two spherical conductors of radii 4 meter and 5 meter are charged to the same potential. if sigma 1 and sigma 2 be the respective values of the surface density of charge on the two conductors, then the ratio sigma 1 by sigma 2 is. You can see that this is a question from the second chapter, potential chapter, but in the same question the idea of surface charge density is also used. Sigma 1 and sigma 2 are the surface charge density. What is surface charge density? Surface charge density is charge per unit area. Now let us understand the question. This is a bit tricky. Be careful. Two spherical conductors of radii, one is 4 meter, next one is 5 meter. Charge densities are sigma 1 and sigma 2. I'm just leaving that 4 meter and 5 meter now. I'm just taking two spheres. Listen all of you please. This is my first sphere. This is the second sphere. They are having different radius. Okay. So the radius of this one I am taking as R1. Radius of the first sphere is R1 and the radius of the second one is what? R2. And these two spheres are given some charge. They did not mention what is the charge. Only charge densities are there. Okay, I am taking the charge on the first sphere as Q1 and the charge on the second sphere as what? Q2. This is okay. Now, it is given that, read the question carefully, two spherical conductors are charged to the same potential. So, potential of the first sphere is equal to the potential of the second sphere. So, if I am writing V1 as the potential of the first sphere, what is the formula for potential? Due to a charge, here charge is Q1, radius is R1. So potential on the surface, you know that it is equal to 1 by 4 pi epsilon naught. All of you know this formula, 1 by 4 pi epsilon naught Q by R. So what is the charge here? It is Q1 divided by the distance is R1. So 1 by 4 pi epsilon naught Q1 by R1 is the formula for the potential on the first sphere. And what is the potential on the second sphere? V2 is equal to 1 by 4 pi epsilon naught Q2 by, these are the two potentials. Is it okay? Right. Now in the question it is given that the potentials are same, which means V1 is equal to V2. Equate V1 is equal to V2. What is V1 value? 1 by 4 pi epsilon naught Q1 by R1 equal to 1 by 4 pi epsilon naught Q2 by R2. What you can see, this 1 by 4 pi epsilon naught will be cancelled on both sides. It's common. Q1 by R1 is equal to Q2 by R2. What is Q1? Q1 is charge on the first sphere. Q2 is the charge on the second sphere. In the question, did they give charge? No. But charge density is given. What is charge density? Charge per unit area. So if sigma 1 is the charge density of the first one, sigma 1 will be charge by area, Q1 by, what is the area of the first one? It's a sphere. What's the surface area of a sphere? 4 pi r square. So we get 4 pi r1 square. This is sigma 1. In the same way, you can write sigma 2 is equal to second charge, it is Q2 divided by its surface area. It will be 4 pi r2 square. So from this you can easily write Q1 will be equal to sigma 1 into 4 pi r1 square. So I am writing here Q1 value is equal to, you can take this here. So we get Q1 is equal to sigma 1 into 4 pi r1 square, and there is an r1 in the denominator. So sigma 1 into 4 pi r1 square by r1 is equal to, substitute for Q2. What will be Q2? From here you can see Q2 is equal to sigma 2 into 4 pi r2 square. Sigma 2 into 4 pi r2 square divided by r2. Okay, 4 pi cancel. This r1 and this one r1 from here cancel. This r2 and this will be cancelled. What is the question? What is sigma 1 by sigma 2? We have to find the value of sigma 1 by sigma 2. We got it, r2 by r1. So this is like a general formula, you can keep it in your mind. Sigma 1 by sigma 2 is equal to r2 by r1. r2 is the radius of the second sphere, r1 is the radius of the first sphere. Come back to the question. What is the radius of the second sphere? It is 5 meter. What is the radius of the first one? 4. So r2 by r1 means what will be the answer? It will be 5 by 4. We got it. 5 by 4. 5 by 4 means it's option C. Option C is the right answer. So please understand step by step. We are finding the potentials on both by considering the charges as Q1, Q2, writing the formulas, equating them, then writing the charge in terms of charge density, because in the question it is given as in terms of charge density. Okay, so clear? Going to the next. Question number 14. The minimum electrostatic force between two charged particles placed at a distance of 1 meter is. Look at that question. The minimum electrostatic force only they are asking. Force between two charges. Force between two charges, the minimum force, distance is 1 meter. So distance only is given, right? And they are asking how to find the force. What is the force? Minimum force. What are the values of the charge? Charge value is not given. No? Then how can you find the minimum force? See, what is the formula for force? Coulomb's law. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the formula. Yes or no? Minimum force between, the distance is given as 1 meter. Minimum force means this 1 by 4 pi epsilon naught value is fixed. It is 9 into 10 power 9. Okay. Distance is given as 1 meter. So denominator will be 1 square. 1 square is 1 only. Okay. Q1 and Q2. For the force to be minimum, we know that the charge should be minimum. What is the minimum value of charge? Here you have to recall the idea of quantization. Basic charge, the minimum value of charge is charge of electron. You can't get a charge which is less than the magnitude of charge of an electron. So minimum possible value of charge is, it is charge of an electron. What is the charge of an electron? It is 1.6 into 10 power minus 19. This is the minimum possible value of a charge. Yes, one doubt is there. Dhruvil, I'll come back to you. Okay. So 1.6 into 10 power minus 19, and the second charge is 1.6 into 10 power minus 19 again. Hope you understand this one. Minimum value of charge means it is a basic charge. What is a basic charge? Charge of an electron. You can't make a charge which is less than the charge of an electron. So we are taking the minimum value. Now just a calculation only. So it will be 9 into 1.6 into 1.6. 16 square, 256. So it will be 2.56 into 10 power minus 19 minus 19 minus 38. Minus 29 will get minus 29. So 2.56 into 9. So it will be around 23 point something. 04 will come, 10 to the power minus 29. Check the options. Yeah, there is only one option related to it, 2.3. Yes, you can change the power. 2.3 into 10 to the power minus 28 will come. So option A is the answer. Option A is our right answer. Okay, please copy it. What is it out? In the 13th one, we take sigma Q by A. So then it will be get to your question actually, right? Then it will be inverse of R square. One R will be cancelled, Dhruvil. One is there in the numerator and one is there in the denominator. Okay, so here, see R1 and this R1 is getting cancelled. Yes. I think this question is also very clear for all of you. So the answer is 2.3 into 10 to the power minus 28. I am going to the next question, number 15. 2 point charges placed at a distance r in air experiences a certain force. In air it is experiencing a certain force, 2 charges. Then the distance at which they will experience the same force in a medium of dielectric constant K is. So 2 things are there to be noted. 2 charges are there. In air it is placed at what distance? R distance. It is experience a certain force. Then the distance at which they will experience the same force. So in air, what force is experienced? The same force it should experience in another medium. Its dielectric constant is given as K. Then at what distance? So what we can take here is, see, this is air. In air, you can assume these are the 2 charges. They are kept at the distance R. It's in air. Then in medium, we don't know the distance. So we are taking x as that distance. So we have to find the value of x. But the dielectric constant of this one is what? K. Then what is the value of x? It is given that the forces are same. What is the formula for force in air? Force in air, I am taking it as F1. So force in air and force in a medium, both are equal in this question. Force in air, force in first medium is equal to the force in second medium. Formula for force, directly you can write 1 by 4 pi epsilon naught. This is in air, Q1, Q2 by what? R squared. This is formula for force, Coulomb's law in air, in free space. It is equal to the force in a medium. What is the formula for force in a medium? 1 by 4 pi epsilon naught, epsilon r. What is epsilon r? Dielectric constant. But here that dielectric constant value is given as k. So what you can write? 1 by 4 pi epsilon naught, epsilon r is k. Charge is same, q1, q2. Distance is what? X square. We have to find the value of x. Cancel the common terms. Q1, Q2 will be cancelled. We have to find the value of x. So we can see that kx square is equal to what? R square. So x square is equal to what? R square by k. X will be square root. Square root of R square is R by root k. Very simple. So the answer for the question is R by root k. R by root k. Which option? Option C. R divided by root k. Okay, so we just go then. Yeah, right answer. Very good. Yes. Copy this. Clear? So these type of question also you can see in many papers. Just we are writing the formula for Coulomb force in air and medium, equating, you can easily find. I'm going to the next question now. Question number 16. It's a knowledge based question. The following is not a property of charge. Which of the following is not a property of charge? Easy. I am expecting all the students. Please comment your answer. It's very simple. Charge is scalar, charge is conserved, charged bodies interact by exerting forces on one another. Charge can take any numerical value. Please comment your answers. Charge is scalar. Is it correct or not? Of course, charge is a scalar quantity. Charge is conserved, one of the property of charge. Charge can neither be created nor be destroyed. Charged bodies interact by exerting forces on one another. Of course, charge can exert force on another charge. Charge can take any numerical value. That is our answer, because as per quantization principle, total charge is an integral multiple of the basic charge. So the answer for this question is yes, option D. Charge can take any numerical value. That's wrong. Charge is always an integral multiple of the basic charge. Yes, very good. Yeah. Next. Question number 17. If the plates of a charged parallel plate capacitor are pulled away from each other. Yes. Plates of a charged parallel plate capacitor. See. These are the two plates of a charged capacitor. It's a charged capacitor, which means charge is fixed, Q. And we are pulling the plates apart. So initially you can take the distance as what? D, and we are pulling the charge apart. Okay? Then there are four options. We have to find which is correct. So the first question is capacitance increases. Well, that's the first option given. When you are pulling when you are increasing the distance between the plates, it's saying that the capacitance increases. Is it correct or not? We'll check. What is the formula for capacitance? E is equal to epsilon naught A by D. This is the formula for the capacitance of a parallel plate capacitor. So what is happening here? When you are pulling, D value is increasing. D is in the denominator. So when D increases, what happens to the capacitance? Capacitance will decrease, right? Capacitance decreases. So this first option is wrong. Okay, capacitance decreases. Got it? Now, option B, energy decreases. What is the formula for energy? Energy of a capacitor. Here, we have an idea about capacitance value and charge is Q. So we have a formula for energy. U is equal to what? Q square by 2C. Q is constant because it's a charged capacitor. Q is fixed. Then we have to check what is happening to C. We already got an idea that capacitance decreases. When capacitance decreases, what will happen to the energy? Energy will increase because it is in the denominator. So when capacitance decreases, the energy will increase. But what is the data given? It is saying that energy decreases. It is also wrong. Energy decreases. Now the third option is about the voltage. What is happening to the voltage? That's what we have to check. Which formula? Direct capacitance basic formula. C is equal to Q by V. V is equal to Q by C. Q by C. We got that the capacitance decreases. When capacitance decreases, what will happen to the voltage? Charge is constant, please note that. So when capacitance decreases, voltage increases. Voltage increases. Yes, that's our answer. So when we are increasing the separation between the plates of a charged capacitor, what is the answer? Voltage increases. Voltage increases. Okay. This is question number 17. Now next 18. Look at this. Electric charges plus 10 microcoulomb, plus 5 microcoulomb, minus 3 microcoulomb and plus 8 microcoulomb are placed at the corners of a square of side √2. The potential at the center of the square is. So there are 4 charges. You can see 4 different charges. Out of the 4 charges, 3 of them are positive charges and there is a negative charge as well. We are placing at the 4 corners of a square. Then what is the potential at the center of the square? At the center, what will be the potential? So let us draw a square first. Look, let it be the square. Okay. Here we are placing plus 10 microcoulomb. That micro we can substitute later. This is plus 5. Another corner there is minus 3 and here plus 8. Plus 8. Net potential at the center. So there are 4 charges. That means how many potentials will be there? There will be 4 potential. We have to add the potential due to all the charges. You know the formula. Formula for net potential V is equal to potential due to the first charge plus potential due to the second charge. Idea is 1 by 4 pi epsilon naught Q1 by R1 plus Q2 by R2 plus Q3 by R3 Q4 by R4. There are 4 charges. We have to add potentials due to individual charges. But the problem is they did not give the value of distance. Which distance? Asking the potential at the center. So we need this distance. And you can see that that distance will be same for all the charges. We have to find that distance. What is the side of the square? It's given as √2. So this side is √2 means this is also what? √2. Use Pythagoras theorem, you will get this distance. The total distance. The diagonal you can easily find. What will be the value of the diagonal? B is equal to root of √2 square plus √2 square. √2 square is 2, 2 plus 2, 4. So we get what? Root of 4 is equal to 2. So the total length of this diagonal is what? 2. So half of them will be 1 meter. So what is the distance from corner to the center? It is 1. That means the value of R1, R2, R3, R4 all are 1. So now the answer will be very easy. V is equal to, what is the value of 1 by 4 pi epsilon naught? 9 into 10 power 9 into, distance is 1 only, leave it. Q1, what's the first charge? Plus 10. And all are micro. Micro means 10 power minus 6. So that also we can write or take outside. So 10 raised to minus 6 divided by 1 meter into Q1 value plus 10, 10 plus 5 minus 3 plus 8. Okay, so we get 9 into 10 power 3. 10 plus 5, 15, 15 minus 3, 12, 12 plus 8, 20, 20. Okay, 9 into 2, 18. So it is 180 into 10 power 3. Okay. Into 9, 180 into 10. Oh, so it is 18 into, yeah, 1.8 into 10 power 5 will come, right? This is our answer. 1.8 into 10 power 5 volt. Option D. D is our right answer. Yes. The potential at the center, right? Okay, so Now the time is almost finished. I hope all the students enjoyed this session. So as I told you at the beginning, those who need the PDF format of the discussion part, you can contact, like apart from the students of Brilliant Group, they will get it in their class group. Those can contact in the number, our official number, which will be available in the website, or you can see here. And tomorrow, you can see again with another subject, another teacher. So all the best for your board exam. Thank you very much. Take care.
Coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.